So in this video, we're gonna explain something really important, which is inflammation mechanisms. They ask about this a lot. Um, the inflammation, it just responds to action or responds to injury. And it's like, it has like two types, infectious and sterile. Okay? So infectious, sterile. So in the infectious, it's just about like bacteria, viruses, maybe like parasites. All of those they called like bombs. And in the other side, the sterile type, it's just something like DNA, RNA. Sorry. How is this RNA? Wait. So RNA or like uric acid. All of those. Sorry. All of this called like dumps. So we have dumps and bombs. Bombs, for example, here bacteria, viruses. Dumps, for example, like RNA or DNA or uric acid, etc. So let's move on. So those type, it has, let's imagine this is the cell. And once this like bacteria is like entering the cell, and once one of the dumps enter the cells, there is receptors. Of course, there is receptors. Just telling the body there is something. So for the bombs, the receptor is called BRR. That's, in the book also, it's pattern recognition receptors. For the dumps, TLR, which is tool-like receptors. So for the bombs, BRR. For the dumps, TLR. Inside the cells, we have something called NF-κB. Where is this NF-κB? The NF-κB is just in every single cell, and it's inactive in your inactive form because there is like enzyme NF-κB inhibitors enzyme, which is like inhibit or inactivate this part. Once it enters the bombs or the dumps, it goes directly to this type, to the NF-κB. What's gonna happen? And when they go there, they activate the NF-κB. The NF-κB is induced and go down to the pro-inflammatory DNA. What they do in the DNA? They transcript it. Once it's transcripted, like damage or something, it will lead to inflammation. Got it? So the dumps, I'm gonna repeat it so quick. We have two ways, oh my god, what is this? So we have two ways or two types of the infection, of the inflammation, sorry. We have the infectious type and the sterile type. And the infectious type, it's called like the bombs, which is examples as bacteria, viruses, parasites. The dumps, as example, DNA, RNA, or uric acids. So when the bombs goes to the cells, it has like special receptors, like pattern recognition receptors. When the dump goes to the cell, it has also special receptors, toll-like receptors. If you have to, if you can remember the whole name of the receptors is good. If you couldn't, just say BRR or TLR receptors. Anyway, in the cell, there is something called NF-κB. It's inactive form. It's like sleeping. When the TLR receptor, the DOM enter to this receptor, the receptor goes to this place, and the R goes to this place, the BRR receptors. They wake, NF-κB up. Like, hey, wake up, there is something. So the NF-κB goes down to the gene, to the DNA, and do something that's called transcript of the DNA. After that, it leads to inflammation. This is the first step for the for the bumps and the DOMs. Here in the other side, in the strial, it has another way, which is in activation of inflammasomes. You're gonna ask, what is inflammasomes? So inflammasomes is just multi-protein. What it can do, how this inflammasome can lead to inflammation, because once the inflammasomes activate, it leads to activate the pro-inflammatory cytokines like IL-6, etc. The pro-inflammatory cytokines in the cell already, as in NF-κB, in inactive form, like sleeping. So the inflammasomes goes and then activate the pro-inflammatory cytokines, and that leads to what? To inflammation, of course. So this is all about the inflammation mechanism. I hope it's clear, and if there's like a question, so just hit me up in the comment below. I told you, like, if you couldn't remember the pattern recognition receptor, just say the abbreviation. And it's important to know the DOMs, what are the DOMs, like what are the DOMs, like DNA or RNA or uric acid, what are the BOMs as well, and to know what is the role of the NF-κB for the inflammation. I told, like, activate and then goes down to the gene, pro-inflammatory gene, and then do transcripted of the gene or of the DNA, and then leads to inflammation. What is the role of inflammasomes and the definition of inflammasomes? You need to know, and I hope this video it's useful and helpful for you guys for better understanding. And thanks for watching.